So hello guys and welcome again to my YouTube channel. So today we will be talking about network theorems, and first theorem we will see is Thevenin's theorem. It is very important theorem. We use this theorem to transform a complex circuit into a much simpler circuit by using the Thevenin's theorem. What we do is we remove the complex circuit around the load and we replace it by a single resistance and a single voltage source. So let us look how we do it. Suppose we have a circuit which is complex and will take a lot of time to solve. So suppose this is R1, R2, R3, V2 and V1, and this is our load. This is our load RL. So what we want to do is transform the complex circuit around this load. We want to transform this portion of the circuit to a simpler circuit across this load resistance, because my interest at this point is to observe and analyze this resistance. I just want to analyze this resistance. So what I will do is make a simpler circuit, only one voltage source, only one resistance, and this load. So this is the RL, this one is this is called as Thevenin's resistance RTH, and this is called the Thevenin's voltage VTH. So solving this simpler circuit will be equivalent of solving this complex circuit if we try to analyze this load resistance. Okay, so whenever we change a complex circuit into a simpler circuit consisting of a VThevenin and RThevenin, all the characteristics of current and all the characteristics of this mesh analysis for this resistance will be the same. So it's much easier to solve this one. It's much easier to find the I, the load current in this easy single mesh circuit, right? So how to convert any complex circuit into a Thevenin's circuit, we will discuss the steps in next frame. Okay, and one more thing, in the last example, the load can be any resistance, whatever across whom I want to form the circuit. I will follow the steps for that resistance. Okay, I can choose any resistance which I want to analyze, and I can make its Thevenin's equivalent circuit. Okay, so let's start steps. Step number 1, you can note down its steps. Step number 1 will be to remove the load. To remove the load resistance, which is RL. So across which resistance I want to make the Thevenin circuit, I have to remove that resistance. For example, I have this circuit. Okay, let us take an example of this circuit. So I have this circuit, and I said this is my load. this is my RL, this is my load. I want a circuit across this resistance which consists of RTH and VTH. So I have to get the VTH value and RTH value. First step I have to do is to remove the load resistance from the original circuit. So what that means? That means removing this one. I removed and I named terminals A and B. Okay, this is the example. Okay, so what I have done, I have removed the load. The load was present, I removed. Okay, this is I removed the RL from the original circuit. Step 2, calculate voltage, that is VTH across the terminals, of removed load. So what is my step 2? Step 2 is calculate, that is VA minus VB for the example. So after removing the load which was present here, I have to find voltage drop across this point. Okay, I have to find voltage drop between two terminals. So one terminal after removing the load, this is my one terminal, this is I named as A, and another terminal is B. So this is A and this is B. So my second step will be, I have to calculate VA minus VB, that is a potential drop across these 2 points. I have to calculate potential drop across these 2 points using mesh analysis or something like that. I have to start from here and go like this and come again to here. So all the potential drop in any path will be VA minus VB. Any path I can choose. I can start from like this and I can go like this. All the potential drops will be VA minus VB or like this. Okay, I can do anything. Now next part, that will be Thevenin. Now for calculation of RTH, what we have to do, open circuit current source if any, and short circuit voltage source if any, and calculate RTH, that is resistance across A and B terminals. So first step was to remove the load resistance, second step was to calculate VTH, and last step will be to open circuit if any current source is present and short circuit if any voltage source is present. So in this question, in the original circuit I have only 1 and 2 voltage sources. So what I have to do is short circuit these voltage sources. Okay, short circuit. I have to short circuit the voltage sources, and now I have to calculate the total resistance across these 2 points. I can easily see this R1 and R2 are in parallel. These 2 points are same. So resistance between A and B, which will be equal to R Thevenin, will be equal to R1 parallel to R2. In this case, that will be RTH. So I will be able to know RTH and VTH. If suppose some current source was present in this circuit, so what I will do, I will just leave as open circuit. So the net resistance will be only R2. Between A and B, only R2 is in a complete circuit. So this is open circuit, so this will have no value. Okay. So these were the 3 steps which we have to follow in order to get the Thevenin's circuit. Finding Thevenin circuit across Thevenin's circuit across 2 ohm resistance. So this is our load and I want to form a circuit around these two. So step 1. What is the step 1? Remove the load. Remove the load is the first step you have to follow. I remove the load and mark the terminals as A and B. So this is our first step to remove the resistance across A and B, which is the load resistance, and to find voltage Thevenin. With the Thevenin is nothing but voltage across these 2 terminals. This is voltage Thevenin. So how to calculate Thevenin? We have to find VA B, which is equal to VA minus V. That means start from A and again come back to B or in any path and write down all the voltage drops or rises according around these points. Then we will be able to know what is the value of VAB, which will be equal to V Thevenin. Okay, very simple. Now one more thing, when you are going A to B, at the end we will be making circuit like this. Be very clear with the signs. I always say electricity is all about signs and how you are how you are assuming the directions and the signs. Okay, it's very important. For example, I am going to make a circuit like this. So my end motto is to make a circuit like this. Okay, and this is our load. So suppose VAB came negative, then that means A point, this is the A point, this is the terminal. Okay, I remove the resistance from these points A and B, the load. So if it comes to be negative value, then make the battery like this. So A will be at the negative. From when you go from A to B, you should encounter the negative first in this voltage. And suppose it's positive, then you put the battery like this in the final circuit. So before solving the question, I am telling you about the science and how to deal with the science and how to follow the science. Okay. Now to calculate VTH, which is equal to VA minus VB, I will. Okay, so this is an open circuit now, because this is open, so no current will flow. I equal to 0, because this is an open circuit now. Now current is gonna flow. Okay, so only current will flow in this direction. Let us suppose I. So let write down the equation. Start from this point and again come to that point. So first I am encountering plus 40 volts. Now go like this, plus 10 I1 10i minus 20 plus 5i equal to 0. Solving this equation, we will have 15i plus 20 equal to 0. That is I equal to minus of 20 by 15. So I get I equal to 4 by 3. So it is minus of 1.33. So I got my direction of assumption of the direction of the current I is wrong, which is indicated by this negative sign. Otherwise, the magnitude of current flowing is 1.33. So now how to calculate VA minus VB? So VA minus VB equal to start from this point. VA minus VB will be start from A and anyhow reach B. Either you come like this, or this is also the path. You can follow any path and just come to B, and this is VA minus VB. Okay. Now, suppose I start from A itself. So I will come like this. Okay. When I come like this, what is the potential drop across this 10 ohm resistance? This is the 10 ohm resistance. What is the potential drop? IR. So what current? I am coming like this. I want to go to A to B. I am coming from up to down. Okay, I am coming from up to down. So what current is flowing up to down? I already assumed the I to be flowing from down to up. The I is flowing like clockwise from down to up. But I am from if I coming from here A to B, I am coming from up to down. But here I already assumed to be the I to be flowing from down to up. So from up to down, minus I is flowing, minus I into 10 ohm resistance. Okay, and then plus I hit the plus first, plus 10 will be equal to VAB or equal to VTH. Okay, so but I is already negative, so minus I will be equal to plus. Okay, so because I explain you. Okay, I again explain you that this part I assumed I to be like that, and from A I am coming like this. I want to go to A to B. So what is the potential drop if I am coming from like this? So this current will be equal to opposite of this current, because none other current is flowing. Okay, so when I say from what current is flowing from up to down, it is just opposite of what current is flowing down to up. I assume to be this I. So from I, if I say from up to down, it's flowing minus I, because it's an open circuit, so no other loop current is present. I2, I3, I2 is not present here because no current is flowing. I equal to 0. So only current is here, it is I, but from up to down it's minus I, and if you say down to bottom it's I. Okay, so but already the I was negative, so I minus will be plus, equal to plus of 10 into 1.33, 13.3 plus 10 equal to VTH. VTH will be equal to 23.3 volts. So the circuit will be, so VTH I got. So now I will be wanting to find the RTH. Okay, so just don't confuse at all. Okay, since I am coming from A to B, from up to down, that's why I used minus I, because I assume that I, positive I, to be like this. That's the other thing that the I itself is negative, so minus getting plus. Otherwise you can also like this. If suppose I came negative, that means 1.33 amperes is flowing like this, not like this. So when you start from here, you know 1.33 is flowing, so it will be plus of 1.33 into 10. That's it. Okay, so that's why you have to be very strong at the sign conventions if you want to be very good at this analysis of electric circuits. Okay. or otherwise whatever you assume, you just keep on following that. Okay, what I assume, current to be like this, I am coming from this now like this. So if I is flowing like this and no current is here, so if I coming from that to that, from top to bottom, then minus I have to write, because I assume I to be like this. So if I want to write a potential drop from A to B and I come up to down, so it will be minus I. If I is flowing like that, if I is flowing from down to bottom, from down to up, okay, it is same as minus I flowing top to bottom. Okay, I flowing down to up is same as minus I flowing top to bottom. This is very important concept. Okay, so since I assume this direction to be positive, coming like this, I am coming like this. So the potential, the current is from top to bottom minus I. So I written minus I into this resistance 10 plus, here I encounter 10 plus, so 10. Okay, you are very careful about the signs. Okay. Now the next step is to calculate the Thevenin resistance. So how to calculate Thevenin's resistance? I already told you one thing. The steps already I told you. So this is our load. We already opened the load. So what we have to do is short circuit all the voltage source present. We short circuit the voltage source. So now we have a 10 ohm resistance and a 5 ohm resistance, and here also we have to short circuit. So RTH will be net resistance across these two terminals. So in across these two terminals, these two are in parallel. So RTH will be equal to 5 parallel to 10, which will be equal to R1 R2 50 upon R1 plus R2 50. 3 is 45 and 5 3.33 ohms. 3.33 ohms. Okay. So here is the R Thevenin. So the net circuit will be, okay. So VTH is plus here. It's plus, and I went from A to B. So going A to B, it's positive. So A will be positive, connected to positive terminal. So first this is the load. This is the load. A 2 ohm resistance equal to RL. B value of RTH is 3.33 and positive is terminal is to be connected from A. Value of 23.3 volt equal to VTH. So this is the Thevenin's circuit reduction. Okay. Now I want you all to know one more way of finding RTH. It will be very useful when dependent sources come. Okay, if suppose you are not able to solve, it was very easy. R1 parallel to R2. If some complex circuit is there, so what you can do is you can also find. Suppose you remove this and make it A B. You make it short circuit. Okay, like this. So another way to finding RTH is, we know VAB, which will be VTH. So RTH will be, if I can find this current after short circuiting this 2 point, if I can find IAB, I which is flowing from A to B, Note this point, IAB, which is flowing from A to B, I assume to be like this. So RTH will be VAB upon IAB. So this is also a way to find RTH. Let us see how can we can find. So this is the circuit, okay. There will be two equations, okay. Equation number 1. So equation, this is I, this is I2, this is I1. So two equations, first one will be 15I1, 15I1, equation 1, 15I1 minus 10I2, 10I2. I start from here and going like this, we all know how to solve this. Plus 20 and minus 40. So plus 20 and minus 40, it will be minus 20 equal to 0. We got I1. Let this be the first equation. And second equation, minus 10. 10I2 minus I1 plus 10I2 minus 10I1 equal to 0. I remove the load and made short circuit and I just calculated the current IAB. Okay. So it will be equal to I2 minus I1. I2 minus I1 will be equal to 1. I want to find I2, so I1 will be equal to I2 minus 1. So putting in this equation I2 minus 1, so it will be equal to, I am putting value of I1 in this equation, okay. So it will be, you can see it will be from here and going to here. So it will be 15 I2 minus I1, 15 I2 minus 15. We put like this, minus 10 I2 equal to 20. So in short, 5 I2 will be equal to 35. So I2 will be equal to 7 amps. So I2 is equal to IAB here, because I assume this is the direction of I2 I assume, and this is also the direction of IAB I assume. So directly same direction, same current will be same. So I2 will be equal to IAB. So I now know IAB. So what is VAB? VAB already we know 23 point. So VAB, so RTH will be equal to VAB 23.33 upon IAB will be equal to, I am using this, will be equal to, which will be equal to I2. And what is I2? 7 amps. So which will also give 3.33. Which will also give 3.33 ohms. So we learned two methods to know RTH. What was the one? Is the conventional method. What is that? Open circuit the load terminals, short circuit all the voltage source, open circuit all the current sources, and calculate the net resistance across these 2 points using series, parallel, or whatever method you want to know. Otherwise, if you know the VTH, you can just make it short circuit. And if I have VTH equal to VAB, if you calculate like VAB, so you calculate voltage from A to B, then also find what current is flowing from A to B and divide it to get RTH. Okay. So this is very important concept. Okay, this is very important concept because you can use any method to find RTH, either series parallel technique or this method, but this method will be very useful in next lectures, okay, when we will solve dependent voltage source. So we will look one more problem in which a current source is present. We will solve one more question. So here also we have to reduce the circuit into, this is our load, this is the load resistance. We have to reduce the circuit into a Thevenin circuits. In a Thevenin equivalent circuit. Okay. So this is 10 ohm. A, B, here it is. A, B, and this is Thevenin resistance, and this is Thevenin voltage. So we have to reduce this circuit into this circuit. So here it's a current source is also present in this case. So step 1, remove the load. So first step is of course to remove the load. Remove the load. Now V Thevenin will be equal to VAB, which will be equal to VA minus VB. We have already discussed. So here I1 and here I2 is flowing. So there are many paths to know VA minus VI. I can go like this, but I have to avoid this path because what I already discussed in previous lectures that when a current source is present, we don't want a voltage drop across this current source because current is there, so there is a hidden voltage source also present. So we can choose this part to write VA minus VB because a current source is present, we already discussed. So we can choose this path or we can choose this path. Just our motto is to start from A and write down all the drops and reach B. We can write VA minus VB. I will choose this path. So here equation 1, I assume the direction of current like this, and also the current source is maintaining a current of 10 amperes and in the same direction. So directly equation 1, I1 equal to 10 amperes. Okay. Now for I2, write KVL 30 I2 plus 10 100 TI2 plus 100 plus 20 I2 equal to 0. Why so? In this bit, in between loop, no current is flowing because it's already open circuit. So solving this 50 I2 equal to minus 2 equal to minus 2 amperes. Okay? Minus 2 amperes. I2 equal to, so I2 equal to minus 2 amperes. So now we want to write VAB. Start from A, 5 voltage across 5 ohm resistance. From top to bottom, I1 is only flowing. This is I1. So it will be I1 into 5. And now like going like this, from down to top, positive of I2 is flowing, plus I2 into 20. Value of I1 is nothing but 10 amperes, 50, 10 to 5, plus I2 will be equal to I2 is just nothing but minus of 2 amperes, okay? Minus of 2 into 20 equal to 10 volts. So VAB equal to VTH equal to 10 volts. So we know the Thevenin voltage as of now. So now we can either short circuit this and find IAB and divide it with VTH to find RTH, or other way, just easy. This is a simple circuit we can use. Okay, we can use series parallel technique. So what we have to do, open circuit all the current source. Remember the steps, I open circuit the current source and short circuit the voltage source. I short circuited the voltage source. I short circuit the voltage source, open circuit the current source. Now and also remove the load. So what is the resistance between these 2 points? These 2 points I can see, first of all, these 2 are in parallel, and this, the resultant of these 2 will be in series with this 5. So RAB equal to RTH will be equal to 5 plus 30 parallel with 20. So this the resultant of these 2 parallels will be in series with this 5 ohm, so it's directly getting added. So it will be equal to 5 plus 30 into 20 upon 30 plus 20 ohms. So it will be equal to 5 plus 600 upon 5 plus 12 equal to 17 ohms RTH. So the resultant circuit, so VAB is positive. So VAB is positive, so A will be at the higher potential. So this will be plus minus 10 volts. Okay, and now the RTH is 17 ohm. So if I want to know the load current IL, so IL will be equal to voltage upon total resistance, 10 plus 7. So by this way we will use Thevenin's theorem to reduce the circuit into a simpler form, reduce any complex circuit into a simpler form, and we learned many things about the sign convention, how we have to assume our direction and signs. We have to be very clear, and we have to always follow a definite path in different signs. And also we learned 2 ways to find RTH, not only the series parallel but also by sorting the terminals. Okay, so which will be very useful in the case of dependent sources, which will be a little complicated, and we will see it in the next videos. So please keep subscribing my channel and please support me. I will be covering all the important aspects in electrical engineering course syllabus, and also I will be starting 11-12 physics classes as soon as possible. So do subscribe, and thanks for watching.